All right, let's dive in. We're about to unpack a breakthrough that isn't just about making faster computers. No, this is about a fundamental shift in the rules of reality itself.
Go ahead and circle that date on your calendar, because according to the source material for this explainer, that is the exact moment the impossible became possible, all thanks to one single breakthrough from Google.
So, what happened? Google's Willow quantum chip solved the problem that our very best supercomputers couldn't crack in the entire age of the universe. But, and this is the crazy part, as mind-blowing as that is, it's not even the most important piece of this story.
What's really going on here, what's truly at stake, is that we are literally watching a new law of physics being born. And it means we're throwing out a rulebook that has governed all of our technology for the last 2 centuries.
You see, for 200 years, this one principle set a hard and fast speed limit on efficiency for everything from old steam engines to modern supercomputers. But what researchers have now proven is that when you get down to the quantum level, those rules, they just break. This isn't just an improvement. This is nature showing us a fundamental power we never even knew it had.
And that brings us to this key idea you're going to hear a lot about: quantum advantage. Now listen, this isn't just about being a little bit faster, it's about crossing a line, a threshold into a whole new kind of computation that was, until right now, basically science fiction. And you might be thinking, okay, cool lab experiment. But it's not just a lab experiment anymore. There's a really clear 3-part pattern emerging that's taking quantum computing from a theoretical concept to a practical reality. So first, these new systems can actually fix their own mistakes faster than they make them, which is a huge deal. Second, we're finally seeing them solve actual, real-world problems. And third, and seriously, this is the one that changes everything, we're starting to tap into brand new sources of energy at the quantum level. 99.97%. That number right there, that's what makes all of this possible. Willow has hit a single qubit fidelity of 99.97%. So, to put that in plain English, that's like having a computer that only makes one tiny error for every 10,000 things it does, all while operating at the speed of nanoseconds. That kind of stability is the key that unlocks absolutely everything else. With that stability, Google's doing something that sounds like it's straight out of a movie. They're creating this tiny, controlled quantum butterfly effect. They just nudge one little qubit, they let that ripple spread through the system, and then they can essentially rewind time to see exactly how it affected everything else. This lets them see deep inside complex molecules in a way we never ever could before. It's a massive, massive leap for discovering new drugs and new materials. But that third breakthrough, honestly, it's even more profound. Scientists have figured out how to take that weird quantum link we call entanglement and turn it directly into work. They are literally pulling usable energy out of the bizarre rules of quantum mechanics. This opens the door to machines that can build things, atom by single atom. So if this is all happening right now, what does the very near future look like? Well, the timeline for quantum advantage has basically been torn up and thrown out the window. It's gone from maybe someday to happening right now. Just look at this roadmap. It is breathtakingly fast. This year, 2025, is all about proving these new abilities. Just 2 years from now, by 2027, we're expecting systems that are fault-tolerant, meaning they can run complex problems for a long time without crashing. By 2028, commercial services will start to roll out. And by 2030, you'll see hybrid quantum classical systems as a common tool in research labs. The future is getting here way faster than anybody thought. And the shockwaves from this, they're going to hit everywhere. Drug discovery is going to accelerate like crazy. We'll be able to design incredible new materials, maybe even room-temperature superconductors. AI is about to enter a whole new phase. Our financial and climate models will become so much more accurate. And then there's cryptography. And, well, that's where the story takes a turn. Because, any technology this powerful is always a tool. And any tool can be used to build things up or to tear them all down. And quantum computing is probably the most powerful tool we have ever imagined. And the stakes, they just couldn't be higher. The same tech that could cure diseases could also design new bioweapons. The systems that could discover new materials for clean energy could also break the encryption protecting every bank, government, and military on Earth. We are now in an urgent race to build quantum-proof defenses before quantum attacks become a reality. Okay, so with all that on the table, the insane speed,
the huge promise, the terrifying risk, what does it all mean for us? What's the real takeaway here?
It really boils down to this single idea. The future isn't just for people who can use these computers, it belongs to people who can think in a quantum way. They'll have to start seeing the weirdness of quantum mechanics, things being in two places at once or being connected across the universe, not as bugs, but as features to be used.
And here's the bottom line. It doesn't matter what field you're in. Getting your head around these basic principles is about to become just as essential as knowing how to code is right now. For leaders, researchers, students, quantum literacy is going to be a core skill you need to get through the next decade.
Look, the reality is we are not ready for what's about to happen, but it's happening anyway. This is, without a doubt, the single most important technological transition of our lifetime, and it's going to speed everything else up. So the only real question left is, are you going to ride that wave, or are you going to be swept away by it?